and attach the landing page to that recording so folks can go back and forth between the slide deck and this landing page, should you so choose. So the goal here today is for you to leave feeling confident in your ability to implement this resource if you choose, or parts of this resource. I know from my experience as a classroom teacher, we're going to do what we want. So I hope that you feel inspired to do what you want. These resources are meant to be plug and play if that's what you choose to do, because I remember that being really exciting if I could find something that was pretty much all done for me. But there's always some tailoring that you can do to fit your classroom style and the needs of your students. So everything here are Google products to allow you to do that. So once again, welcome. I really appreciate you being here. We're going to dive into the snow in the Rockies. First, want to acknowledge some of my amazing team, and can't fit everybody on one slide, but lots of encouragement and support from my supervisor, curriculum development colleague, Elise Thurber, and graphic designer, Amy Naku-Schmidt. I think that hopefully the data puzzle, these lessons have a level of polish to them, and I really think Amy's graphics bring that out, so want to thank her for that. And then amongst all the scientists that we've been able to work with, Dr. Melissa Bratton, who's a co-author of Ambitious Science Teaching. It's been really amazing to get to work with her and to integrate some of the research-backed practices that she's spent more than a decade researching and developing and training others to use. So this is just a snapshot of our team. We've got tons of teachers and other scientists working with us, vetting data sets, among other things, but acknowledging these folks. And for those that maybe don't know the story, Jabat, you could probably tell this story by heart now. Data puzzle lessons were inspired by my work with the Mosaic Arctic Research Expedition. So I was hired in 2019 to bring this Arctic expedition to classrooms by developing resources. And we developed a following and had teachers asking for more data from the expedition, data from the Arctic, data from other parts of the world. And we had these classroom-friendly data sets that were embedded into larger units. And I thought maybe I would try to take these classroom-friendly data sets out and repackage them into a more concise product. And so I reached out to our friends at Data Nuggets. So you'll see similarities to data nugget lessons in our work, and worked with them to create a data nugget, but felt like their structure was very rigid, and we wanted to do a little bit more. And so kind of riffed off of their work and infused these ambitious science teaching practices into the resources that we were developing. So you'll see that many of the data puzzle lessons, I think we have about 12 right now, have an Arctic focus. That is because initially that's where a lot of the funding was coming from. And I had a lot of classroom-friendly data sets that were Arctic focused at the beginning. And since then, we've branched out a little bit. We've got a couple of wildfire units, drought units, CO2 temperature, looking at the spatial relationships or lack thereof there. So lots of different data puzzle lessons in our library. Before we get into the snow and the Rockies, I just want to give a brief overview to what are these ambitious science teaching practices. It's a pedagogical framework that has principles, tools, practices to support meaningful and equitable science education. And you'll see that these 4 practices are called out in this ambitious science teaching graphic to the right. In the book as written, we start with this: how do you plan for engaging students with important science ideas? We think about these important science ideas being the disciplinary core ideas as defined by the Next Generation Science Standards. So how do you plan for using those, engaging students with those ideas? How do you elicit student ideas, perhaps about those science ideas? How do you elicit student ideas that could be used for sense making? How do you work with these students' ideas to support ongoing changes in thinking? And then how do you bring it all together to support them and help them explain their thinking using evidence? And so ambitious science teaching provides scaffolds and tools to support teachers in doing these things. And so my idea and what Data Puzzles does is to try to take out some of the thinking and planning and to do it for you. So we do the planning for you. We have prompts and strategies to support eliciting students' ideas about questions or demonstrations that we suggest. We have data sets that support students in changing their thinking. And then supports for having them construct explanatory models. So we're trying to do this for you. And so we've, with permission from the ambitious science teaching authors and support from Melissa Bratton, kind of shuffled at least these two quadrants around. So you're no longer planning to use this important side ideas. We've done that for you. So all data puzzles begin with eliciting student ideas, so revealing resources students bring to the classroom. These resources are, I think, ideas, experiences, or language in the context of an opening scenario. So bringing out what students already know about a scenario that has similarities to the science investigation that they'll be investigating in the data puzzle proper. And so after eliciting students' ideas, students will engage with an interactive reading we call the puzzle plot to learn a little bit more about a featured science investigation. And you, the facilitator, are challenging students to make connections between their experiences, ideas, and language, those resources that they revealed to themselves, to the class in this part one, and make connections between those resources and the science ideas in the new science investigation. And as part of this interactive text and making those connections, students develop predictions about a question a featured scientist is investigating and develop initial models about that question. Students will test this prediction against an authentic data set and this supporting ongoing changes in thinking, and then put it all together in constructing a final evidence-based explanation. So that's the framework. Again, you can see bringing ambitious science teaching into kind of a data analysis, sense-making task, data puzzles. And so wanted to pause here real quick and show you what's available to you. I think that's really helpful before we engage in those four parts together. Wanted to just take us to this data puzzle page that's linked in the landing page. The collection is where all of the resources are. Again, drought, snow, wildfire, lots of other science phenomena to investigate here. When you click view resource, it takes you to this cover page. All the data puzzle cover pages look the same. A little bit of background text at the top, some statements about what students will do, and then the teaching materials, teacher guide, slide deck, student worksheet. This link at the top here, all lesson resources, will take you to a Drive folder that contains answer keys, slide decks, student worksheets, among other things. We open up the teacher guide here, you'll see this draft watermark. As I was explaining earlier, this is a draft resource in that it hasn't been pilot tested by classroom teachers. So just want to make that disclaimer that we will be piloting this with classrooms and then seeking feedback from those pilot teachers and then revising it accordingly. So this will have a draft watermark until that is done. All teacher guides and data puzzles look the same, some background information. The four parts of data puzzles defined here on the first page, estimates about how long I think they will take. Page 2 includes an instructional overview table with connections to the next generation science standards, the question that scientists or students are investigating in the data puzzle, and all of these materials. I want to point out, because it kind of gets lost, that there is always an answer key associated with these. I don't advertise it on that main cover page because I'm trying to be a little sneaky and hide it. I'm sure students could figure this out, but I tried to bury them a little bit, so they're in the teacher guide, in the materials. There's always an answer key available. And then the teacher guides tried to make them concise. They're typically 4 to 5 pages in total. Each of the 4 parts, what you should be doing, explained succinctly, I hope, with some additional teacher resources at the end. Again, I know that folks are going to take these any way they want, and that's really cool. And when I'm doing research for creating these resources, I find a lot of things that I'm like, oh, that's cool, that's cool, that's cool. So I just try to bury those in the additional teaching resources in case folks are interested in learning more or making other connections. So that's what they look like. This resource is different than the others in that has a VR tour. So we had 360 images from field sites next to the Rocky Mountain Biological Lab in Gothic, Colorado, which is near Crested Butte. So we'll check this out in just a moment. That this is 360 click drag pictures. There are some videos, images that pop up, so on and so forth. So trying to take students to the field to see kind of where the data that they'll be analyzing was collected. So I'll give you an opportunity to play with that in just a moment, but wanted to just point out that this resource is a little bit different in that it's got that VR tour component, which is cool. Any questions about what's available to you in this resource? Awesome. Let's dive in then. What we're gonna do now is I'm gonna kind of walk through some slides that are included in the actual slide deck for this resource, just to give you an idea of how you could facilitate this with your students. Again, each of those 4 parts. All data puzzles start with this eliciting students' ideas. I want to point out, I put it in a box right here so I don't forget. This is not included in the student worksheet. So this is something that you would do as a warm-up prompt, as a think, pair, share. We have classrooms do them as like these whiteboarding activities, but this is something that you're doing with students through small, large group discussions. And the goal here is to bring out student ideas about an opening scenario. This could be an image, a video, a prompt, a demonstration that's going to have similarities to the science investigation presented in the data puzzle. So the idea with this is like, all right, and we'll take this for example. We're going to have students investigate like snow in the Rockies. Maybe students don't know where the Rockies are, they've never been there, but they've experienced snow elsewhere. Maybe before we have them think about changing snow conditions in a space they're not familiar with, maybe they could think about what they already know about snow in the place that they are familiar with. And so just a way to kind of softly introduce a science investigation that's going to have maybe some ideas they're unfamiliar with, a place they're unfamiliar with. Before we get into that, what do they already know about snow where they are, about the factors that might lead to big snowstorms, or why isn't there snow this year? Like some of those things. So bringing out those experiences as resources that can be helpful later to help them make sense of new and complex science phenomena. So again, I've mentioned this, different facilitation strategies you could use in your classroom. Again, maybe it's like the structure of your room. In my classroom, I had a warm-up prompt, so I might have students write it down first, then do a think a pair share and then a whole class, or if I had whiteboards, so whatever your style is. In this lesson, the question is just asking students to reflect on their own experience about a snowy winter or a huge snowstorm, wherever it is. What's the biggest snowstorm they've ever experienced, or the snowiest winter? How much snow was there? Did they close school? Does it always snow that much? So just trying to get into their experience here. And I'm sure that students will have some fun stories about this. Perhaps they don't live in really snowy areas, but maybe they've been impacted by a single snowstorm that closed down a city. But bringing those experiences out, asking students to then turn in talk with a classmate about what factors might cause some winters to be snowier than others, or what factors might cause a big snowstorm. So I'm thinking things that might come out would be temperature, moisture in the air. Maybe students talk about clouds. So what kind of factors do they think might impact whether or not there's a snowstorm, whether or not a winter is snowier than another? And we use those experiences, those discussions as a way to introduce the featured scientist, Dr. Janet Intrieri, who studies snow conditions in a specific area in Colorado. So Janet studies snow conditions among many other factors at the Rocky Mountain Biological Lab. It's a science institution in the East River Watershed, kind of near Crested Butte, Colorado. And so Janet and others have been visiting or are part of this project where they're measuring different parameters that impact snowfall among other parts of the water cycle. And so she's not the first to do this. Folks at the Rocky Mountain Lab have been studying snow conditions for more than 45 years. But in 2021, Janet and others set up instruments to study what factors could be causing changing snow conditions in the region. So setting up instruments that measure cloud coverage, temperature, the amount of incoming and outgoing energy, among many other things. So why are these scientists, Janet and others, so interested in studying snow conditions in this watershed, and why does that matter? So I wanted to put this into some context for students. So this Rocky Mountain Biological Lab is shown here with this red triangle. It's about 200 miles southwest of Denver. It was founded in 1928, and folks have done tons of studies up in this area. So more than 1,500 papers have been published based on work from this lab. So that infrastructure is there. And why this matters is because water from this East River watershed eventually flows into the larger Colorado River system, a river system upon which 40 plus million depend on. And so what these scientists are trying to do is understand the factors that impact largely snow, because snow is the biggest contributor of water to the Colorado River. So if they can understand snow conditions in a Rocky Mountain watershed, what causes more snow, what causes that snow to melt, can we make predictions about what that will look like year to year, or improve models or forecasts for snow in the region? We can do it in that one watershed. We might be able to do it in other watersheds in the Rocky Mountains, and then be able to better predict how much of that water will make it to the Colorado River into the future. So that's some of the context why this work is important, why they've selected this East River watershed. After eliciting students' ideas, making that connection, snowy conditions, factors that might impact snow, Janet is doing that in the East River watershed. Here's why the East River watershed matters for so many people. Let's go learn a little bit more about Janet's work and the work of others in part 2, this identifying important science ideas part. And so this is where this is where you would hand out the student worksheet. Here we're introducing important science ideas through this worksheet, this interactive reading that's going to have videos, this virtual reality tour. And so your job is to support students in connecting science ideas from this reading back to the opening scenario. Students are going to be summarizing key ideas by creating an annotated sketch. In this case, the annotated sketch is provided for them, and they're going to be describing it. Students will then identify an investigative question and make a prediction about that evidence-based or an evidence-based prediction about that investigative question. So I'd say primarily we have teachers facilitate this as a whole class or small group read aloud, just so that they can pause to have students discuss a graphic or watch a video together. There's also like a stop and jot question. So a question embedded in the text to challenge students to stop, try to make sense of what they read with a question. So that's primarily the way that classrooms do this as a smaller whole class read aloud. Would encourage you to, if you use close reading strategies in your classroom already, to integrate those into this as well. We don't provide close reading strategies for this work, but I know many classrooms already have those. So if that's in your instructional practice already, would encourage you to use those. In this is directly from the slide deck for the actual lesson. We're going to learn more about Janet's work in this splash project. That's the name of the project, and how snow conditions are changing by reading the puzzle plot text. We ask students to circle the investigative question. This needs to be updated. It's not Seth, it's Janet, and that's a typo because I just copied and pasted this slide deck from last week's webinar. So that's not actually what it looks like in the lesson. And then underline similarities between the reading and the opening scenario. So that's what students are going to be asked to do. And here's what the student worksheet looks like. Page 1, page 2. So kind of problematizing this is typically the first paragraph, introducing the idea that scientists are studying the water cycle, how water moves as solid, liquid, and gas through these mountain watersheds, why we're primarily focusing on snow, because that's where most of the water is coming from, and how that impacts so many people downstream. Picture just showing how water moves through the system, including how energy from the sun is absorbed and reflected. The idea here is to introduce some of these different processes because we highlight those processes in the virtual reality tour. Stop and jot, we're really focusing, the data sets are the timing of snowmelt and the total snowfall over the 1975 to 2022 period. So that's the data set in here. Thanks, Mike. We'll see ya. And so I really wanted to try to focus in on those two things. How does the timing of snowmelt in the Colorado Rockies impact farmers hundreds of miles away? And there's some reference to farmers down here. So again, wanting students to think about why it's important. Why does timing of snowmelt matter? Why does the amount of snowfall matter? The project that Janet's working on is called Splash. And so we introduced this Splash project, where in 2021, scientists set up a number of instruments across the East River Watershed to better understand the water cycle, and what factors that are causing more snow, less snow, snow melt, evaporative rates, among other things. And so reference that Splash project, a video providing an overview of that field campaign. And then we introduce the question that's kind of being featured in this data puzzle, which is how have snow conditions in the East River watershed changed over time? So we're just looking at total snowfall and the timing of snowmelt in the East River watershed. After providing this overview of Splash, maybe watching this video, this is where we send students away to the VR tour to allow them to experience the lab and the Splash project for themselves. This is linked in the landing page. It's in the student worksheet as well, clearly. So we'll kind of let you explore that on your own another time, or now while you're listening. But again, this is like click and drag, experience these different field sites, see some of the different instruments, and learn a little bit more about what the instruments are doing. In the landing page, which I'll add to the chat again, just because I've got it up here and maybe you don't, or maybe you haven't seen it. Here's a link to the VR tour. I'll also note that we created a student worksheet that goes along with the VR tour. That's very much optional. Looks like this. The idea was that there are a number of different scenes, so each 360 image that students can click and drag and experience is listed here as a scene. Within each scene, there are instruments that are described, and it tells students what those instruments measure, and then trying to connect that instrument and those measurements back to the water cycle in some way. So you can definitely do this data puzzle without having students do this worksheet. I chose not to include it in the actual data puzzle lesson just because I didn't want a 10, 12 page student worksheet that can be pretty intimidating for teachers and students. So this is an optional piece. Also have an answer key for this that's in the teacher guide as well. So just wanting to point that out. So trying not to get us all lost here. In this student worksheet, the puzzle plot text, there's this background reading, right? There's a VR tour and an option to have additional questions related to the VR tour if you choose. So that's what we were just looking at. Does anyone have any questions about that? All right, great. So one of the goals of this puzzle plot text is, again, to support students in making connections between their own lives and their own experiences, their own ideas, and what's going on in this science investigation. So there's always a slide like this that forces students to make those connections. So how are you and your community impacted when there are big snowstorms or when it snows a lot in the winter? And how are the people in the Southwest impacted by winters where there's a lot of snow or not as much snow? So trying again to help students make those connections between their experience and what they just engage with in that text. We've already gone through this splash tour. And then after students have read that text, watched videos, played with the tour, had some discussions, making connections between the text and their own experiences. This is when there are a few kind of summary questions where students are asked to describe how the amount of snow falling in the Rockies could impact people hundreds of miles away. Students record the investigative question, which for this data puzzle is how have snow conditions changed over time in this East River watershed? And then students make a prediction about this question. This is a screenshot of the answer key. So you can see this here is showing a year with a lot of snow represented with more snowflakes. We've got this little time bar here representing your distance scale here, representing 200 miles to a big city. So you can see lots of snow, less snow, asking students again to consider why we care about the amount of snow that falls in the Rockies. Whoops, here's the question that Janet's investigating, and then having students make a prediction about that question and supporting their prediction with some evidence. Why do they think this? Again, students will test this prediction in this third part, supporting ongoing changes in thinking, where they're going to test that prediction, their understandings against an authentic data set. In this part, we always encourage teachers to to talk about the graphs with students before having them go off and identify patterns and explain those patterns? How can we support students in getting familiar with the data sets? And a strategy that we often use is to have them identify and explain like one point in the graph. What's the highest point mean? What's the lowest point mean? Um, Identifying and explaining extremes was a strategy that Dr. Bratton in her work with ambitious science teaching said worked well for students. And so we often encourage teachers to do that. A lot of teachers already use this what I see, what it means strategy, WIS-WIM. So this is a strategy where students would be annotating directly onto the graph, basically describing their noticings, what they see, and then what they think it means on that graph. So a way to annotate a graph to identify and explain some patterns. So perhaps you have some other strategies that you already use. That's great. These are slides directly from the slide deck here. So these would be this would be a way for you to have facilitated discussion about a graph, one of the data sets, before they go off and make sense of it on their own or in small groups. So this is a snowfall graph, total snowfall at the Rocky Mountain Biological Lab from 1975 to 2022. So 1975, 2022, this is total snowfall, total accumulation over the course of an entire winter season over this, what is that, 45-year time period. And so we would have students find, all right, well, when was the snowiest year? This year here, close to 1,700 centimeters of snow. That was 1995, 96. So again, just trying to get them, it's kind of like a scavenger hunt. What's that high point mean? I got to go to an axis, the y-axis, the x-axis. You maybe call out and explain these axes like I did as well, but trying to get them to find what these points are, what they might mean. We're not necessarily looking for them to identify any trends here. Again, just becoming familiar with the data set. So this is total snowfall, and this is the timing of snowmelt. On the x-axis here, we've got year 1975 to 2022. And then this is the date when all the snow melted from a particular location at Rocky Mountain Biological Lab. So somebody's been measuring when a particular location, a particular spot at the lab has been totally snow-free, totally melted away, all the way back to 1975. April 15th, this is obviously earlier in the spring. June, July, that would be later in the spring into the summer. So points down here closer to the x-axis, those would be when the snow melted earlier in the spring, earlier in the season. Further away would be a later snow melt. So again, we're thinking about timing here. And in the context back to that puzzle plot reading, we talked about why timing matters. It's why we were talking about farmers in the text and agriculture. An early snow melt might mean you might not have as much water later in the growing season when you water your crops. A later snow melt would mean that maybe that water's rushing into the system a little bit later. You might have water available to you through the entire growing season. So thinking about why snow melt matters in that context is what we're trying to do here. So after giving students an opportunity to look at these data sets in small groups as a whole class, they go off, identify patterns and explain these patterns in context on their own in the student worksheet. Maybe we'll cut to that right now real quick. So in the student worksheet, this is what it looks like. Here's a total snowfall graph. Some scaffolded questions to support students in just like identifying and explaining different points, identifying patterns, kind of an overall decreasing trend here, and then asking them to consider what patterns or what factors might be causing these patterns. So We don't explicitly get into the mechanism here in this data puzzle, like why is there less snow? Why is it melting earlier in the spring? That was a decision on my end, because I didn't want to overwhelm this resource or students with too many data sets. But the idea here would be perhaps from engaging with that VR tour, they might learn a little bit about some of the factors or mechanisms that might lead to more snow or less snow, or earlier or later snow melt. And perhaps they can bring in what they learned from the VR tour and consider factors that might lead to a decreasing trend in snowfall and earlier snow melt. Um, Students do the same with the timing of snow melt. Again, April being earlier in the spring, July, June, later spring, summer. So asking students the day of the year, what date did the snow melt during these different years, what patterns, what factors, and then having them revisit their prediction. Did the data support or refute their prediction for that investigative question? How's the amount and timing of snow melt in the East River Watershed changed over time? The last part of all these data puzzles is this constructing evidence-based explanation piece. And so this is challenging students to bring it all together. Their experience, their personal experiences, evidence and information from the puzzle plot text, the VR tour, the data they analyzed to construct an explanatory model for that question. So some different strategies here. There are more slides in the actual slide deck for this lesson than what we're showing you now. Want to point out that there is some scaffolding here that you could choose to use or not, depending on how comfortable your students might be constructing a model. Models and data puzzles mean annotated sketches. And so you might need to go over what should a final model look like? What should we include? Maybe we look at some examples together. Those of you that have experienced these webinars with me in the past might be sick of this, but there's some basic information about what models are, how scientists use scientific models, what they're trying to do with them, what could be included in a model, different parts or components, connections between parts and components. If you have evidence in the form of data, you could add that to your model as well. And after talking about these different parts, connections, evidence that make up scientific models, ask students to look at this model I drew about the Marvel movie Black Panther, and asked students to identify these different bullet points in this annotated sketch over here. So a kind of a playful way to have students look at some modeling conventions in perhaps a familiar setting for them. This is, again, a slide that you could choose to get rid of if you don't think it serves your needs or the needs of your students, but offering it here as some scaffolding. Also have classrooms a lot of times print this slide out, or again, review it with students. So different modeling conventions, how you could use arrows or keys or zoom in windows, text boxes, some of these different modeling conventions. Again, I tried to integrate all of those modeling conventions in this model here, but something to point students to. In this case, students are, this model isn't really getting into mechanism as much as just like how have things changed over time. But I think it's worthwhile to have conversations with students. I include these two bulleted prompts in the student worksheet and in the slide deck. Asking students to consider like how they could use a snowflake to represent more or less snow. How could you use this water droplet to indicate snow melt? What is this? We've got this like kind of timeline at the bottom, winter, spring. Like, how could you use this timeline and this raindrop to represent snowmelt and when it happened? So this will be something I'd be really interested to see how this pilots with students. It might not really, I'm not sure. This is one I tried to build like a model background image upon which students could annotate. And it would be interested to hear from folks how this works or if they have ideas. But again, I think these conversations about how you could use different signs and symbols in the key to represent different ideas or things that came out in the puzzle, in the data puzzle earlier would be worth your time. Also, having students, giving students space to actually add empirical evidence data here really records the snowfall and snowmelt date. So again, kind of forcing them to use evidence in their final models. Here's an example of what it could look like. I wouldn't maybe expect them to use red. Maybe this is too alarming. I used red just because this is the answer key. I'm trying to say this is the answer key. This is what I'm thinking. A little loud, but we've got some data from the graphs included here. More snowflakes, fewer snowflakes. A later snow melt date, an earlier snow melt date. So again, just kind of shifted these water droplets in this dashed line earlier in the spring, later in the spring. So yeah, I'd be interested to hear how this goes or what folks think about this or if they have other ideas. But this was what I came up with in terms of past, present, trying to show change over time, have students add evidence to those graphs. I mean, to these annotated sketches. So all data puzzles end with a kind of a digging deeper question and challenging students to think about what they learned maybe in a different context. Some are related to social justice issues or thinking about these science ideas with respect to a different phenomena. In this case, I really want to highlight, right, that the data is showing that the East River Watershed is getting a little bit less snow, and that snow is melting earlier and earlier in the spring, and wanting students to actually see what that means and the impact that's had on these downstream users. And so this video I've used in different contexts. I think it's really compelling. It talks about how 40 million people rely on the Colorado River and the impact the mega drought is having on these downstream users. It has a particular focus on farming and agriculture, which is referenced in the puzzle plot text. And so there are some questions in the student worksheet that accompany this video. So again, just, you leave that data analysis piece, students construct a model. They're in the East River Watershed. That's where these data are coming from, but wanting, again, for them to think about like why that watershed matters, why the Rockies matter, how that impacts so many people downstream. Another piece that's not in the student worksheet, but referenced in additional resources, and I'll just point it out. This is an interesting site that I've been looking at, this EPA climate indicators. This is a graph that showed changes in snowfall across the contiguous US. Just pop over to that page. It shows rate of change of snowfall. Red is less snowfall, blue more snowfall, and across the US. So, we were looking at one watershed in Colorado, one spot, but these snowfall patterns are things that folks are monitoring elsewhere. And so depending on where you are teaching, if I were teaching where I'm in Vermont, I would certainly bring up what Vermont snowfall is doing and how that's changed over time. if I were using this resource in a classroom here. So just wanted to point that out. That's the type of thing that we've added to the additional resource section at the bottom of those teacher guides. Yeah, Eric's question, why nothing down here? I'm not sure that perhaps there's, I don't know, maybe just not enough data. I'm not sure these places get snow every year. That would be my guess, but I don't know. Good question.
I wonder if they even collect data because it's so intermittent. Because I know like Atlanta will get snow
Yeah, that's
occasionally.
true.
It makes national news when it happens, but not enough
Right.
to actually measure it.
Totally. Yeah, and Texas has some, of course, but yeah, definitely like these Arctic blasts that are coming south are making national news. So you're right. Yeah, I don't know.
I mean, even California is very, very point specific. Like California gets tons of snow.
Yeah,
Like we flew into Long Beach last spring and there was snow in San Bernardino, like right outside LA. It was
that's
crazy.
right. Well, this is like another thing that I think is cool. It's something that we're thinking about doing for data puzzles. It's like these kind of more polished resources take a long time to make, but maybe we can have data sets and some background information that tell compelling stories for folks to use. And so this EPA climate indicators page, it's got all sorts of different data sets for folks to look at, and then has some background information and key points. So in my like checking out websites looking for cool things, like just happened upon this, something that I could have imagined using in my classroom. So just wanted to point that out here. But yeah, that's snow in the Rockies. That's this lesson. Again, it's not been used. So I like it. I think it's strong. Again, I think that modeling piece at the end could be potentially challenging. But I'd be interested to see what folks come up with, or how students engage with that part. We'll be back at a different time next week. And it won't be me, it'll be my colleague Elise Thurber, who's written up a data puzzle that's looking at wind patterns in the Front Range and how changing climate conditions may or may not have it may or may not be impacting these wind patterns. So really thinking about this is in like the context of wildfire. So fire in Hawaii, there was a fire a couple years ago in the Front Range, right? Like these super windy days where they have these big wildfires coming through. Um, so that's the connection that Elise is looking at there, looking at how has climate impacted winds and thinking about the number of red flag days that folks are experiencing. So again, this one's really front range, Colorado Front Range specific, um, but new and exciting nonetheless.
As an ultimate frisbee player on the Colorado Front Range, I could tell you it's had a pretty dramatic impact on the game.
That's I'm I don't know, Eric. I think we gotta throw it harder.
It's challenging.
In the chat right now, I'm gonna add. I hope the sharing settings are right. If you're interested in a 1 hour PD certificate from the University of Colorado Boulder, please just add your name and your email, and I'll get that out to you probably tomorrow morning. Also going to spam all of the people, hopefully not spam, but send out the recording and the landing page to everybody that signed up for this webinar, just in case someone's interested that wasn't able to attend. So regardless of whether or not you fill out that certificate, you'll be getting one more email from me. Again, that'll be the recording and the landing page. And if you add your name to that Google form in the chat, Dave, do you think you could add your your email to this Google form in the chat? Just that way it's all in one space for me. Easy for me to just pop into that first thing and send out certificates in the morning.
Yeah, I'm looking for the Google form.
Oh, okay. Did I? I'm gonna add it.
I see,
think
I see, I see, I see, I see it there.
you got it. Okay, awesome. Appreciate it, Dave.
Not a problem.
And same thing, Shauna. In the chat right now, there's a. I'll just maybe I gotta label this a little better. This form in the chat, you could just add your name, email to that. That'd be awesome. Right on. That's it for me, team. I'm happy to hang on and chat with whoever wants to chat. Yeah, Shauna, are you seeing the link to that Google form? Appreciate you all being here. And if anybody uses this, Erica, if I haven't really put this out there, if you want to pilot this and work with me, my offer is I can give folks a $50 Amazon gift card to use it, and then really it's probably just a chat via Zoom, like what worked, what didn't work. Awesome. Would you shoot me your email and just chat me in? I'll ping you right now.
Yeah.
Open to anybody in here. If anybody, would like to pilot this, I would love to work with you. And again, what I can offer is a $50 Amazon gift card. Right on. Cool. Erica. Awesome. Appreciate it, Erica. Thanks for asking about that. Again, I feel like that model piece is there'll be perhaps some other weaknesses exposed, but for me right now, that's the part that's giving me the feeling. Awesome. Thanks all. Yeah. Thanks, Rainier. Cool.
Erica, what school do you teach?
I'm at Evergreen High School.
Oh, nice.
Where are you at?
I'm down just outside of Golden Compass Montessori High School.
Nice. Not too far away.
We have some evergreeners that come down the hill to us.
Yes. Yeah, we have kids coming up, and then some of our kids come down. Yeah, a lot of this, I'm a rafter, and so a lot of this makes me think about, our permits of, sometimes we get the permit and there's not the water, or sometimes we just don't get the permits. But yeah, lots of recreational connections to this topic.
Mm-hmm.
Yeah, definitely things the kids will relate to.
For sure. Yeah. And skiing and all kinds of things.
Tubing on Clear Creek.
Tubing on Clear Creek. Yeah. That's a good one. Is there any kind of time frame, Jonathan, you're thinking about with pilots? Does it matter? Or just whenever we get to it?
Doesn't matter. Yeah, when you get to it, I'll shoot you an email, but yeah, whenever you get to it is cool with me. I'm working on, it's kind of like this is done, I start working on polar vortex stuff, and it's like I'm already over my head in this other science concept. Like, so I really appreciate you